Hello everyone, my name is Johnny Fer Bornea, a grade 9 mathematics teacher of Quito Bao High School, Bao Alamada, Cotabato Division. If you are having difficulties in learning mathematics, this is now the time for you to explore and understand the concepts in learning mathematics world. Today, we are going to discuss more about the concept of the sum and the product of roots of the quadratic equation. Here are the objectives for today's topic. First, define the sum and the product. Second, find the sum and the product of roots of the quadratic equation. Third, display accuracy in finding the roots of the quadratic equation. Before going to our discussion, first we will have a short recap regarding with our previous topic about the nature of the roots of the quadratic equation, using the question, what is the use of the value of discriminant b squared minus 4ac in determining the nature of roots? You are right, very good. When the discriminant is equal to 0, then the roots are real numbers and are equal. When the discriminant is greater than 0 and a perfect square, then the roots are rational numbers but are not equal. When the discriminant is greater than 0 but not a perfect square, then the roots are irrational numbers and are not equal. And when the discriminant is less than 0, then the equation has no real roots. Moving on to our topic, first we have to define the sum and the product. What is sum? Sum is a result of adding two or more numbers. What is product? Product is the result of multiplying or an expression that identifies factors to be multiplied. At this time, we will have another activity which helps us to understand and to identify the easy steps later on how to solve the sum and product of roots of the quadratic equation. Given the quadratic equation x squared minus x minus 6 equals 0, what are the roots? Let's check your answer. In solving quadratic equation, we have different methods to solve the roots. But in the given equation x squared minus x minus 6 equals 0, we have to use the factoring method, which is the easiest way. X squared minus x minus 6 equals 0. To factor out the expression x squared minus x minus 6, we have the quantity of x plus 2 times to the quantity of x minus 3 is equal to 0. And now, by using the zero product property, we have x plus 2 is equal to 0 and we have x minus 3 is equal to 0. To solve for our x's, first, we have x plus 2 is equal to 0. By using subtraction property of equality, x now is equal to negative 2. And for our x minus 3 is equal to 0, by using the addition property of equality, we have x is equal to positive 3 or 3. You got the correct answer. Therefore, the roots are negative 2 and positive 3. And now, using the identified roots of quadratic equation negative 2 and positive 3, we can simply get the sum and product of roots of the quadratic equation. So, what is the sum of roots? Correct! The sum of roots is 1. How about the product of roots? You're right! The product of roots is negative 6. Regarding to the activity, what can you observe to the sum and the product of roots and the coefficients of the quadratic equation? I know you're thinking, about the relationship between the sum and the product and the coefficient of the quadratic equation. So now we have to discuss how the sum and the product of the roots of the quadratic equation ax squared plus bx plus c is equal to 0 can be determined using the coefficients a, b, and c. Remember that the roots of a quadratic equation can be determined using the quadratic formula. What is the quadratic formula? Very good. Quadratic formula is x is equal to negative b plus minus to the square root of b squared minus 4ac all over 2a. By the quadratic formula, it will help us to derive another formula to solve the sum and the product of roots of the quadratic equation in an easiest way. And now, the derived formula of the sum of roots of the quadratic equation is negative b divided by a. And in finding the product of the roots of the quadratic equation, we have c divided by a. Using the derived formula of the sum and the product of roots of the quadratic equation, let's try for an example. Find the sum and the product of the roots of x squared minus x minus 6 equals 0. First, in finding the sum and the product of roots of the quadratic equation, we have to identify the value of a, the value of b, and the value of c. In the given quadratic equation, what is the value of a? Very good. A is equal to positive 1. How about the value of b? Correct. The value of b is negative 1. And how about the value of c? Very good. The value of c is negative 6. And now, using the identified value of a, b, and c, we can simply substitute to the formula of the sum and the product of roots. Since we have already the values of a, b, and c, we can now immediately solve the sum and the product of roots. What is now the sum of roots? Very good. The sum of roots is equal to positive 1. How about the product of roots? Very good. The product of roots is negative 6. Let's try another example. Very good. The sum of roots is negative 4 and the product of roots is positive 3. And now, try to answer this for 20 seconds. Very good. The sum of roots is negative 2 and product of roots is negative 3. And now, let's go back to the question, what do you observe to the sum and the product of roots and the coefficients of the quadratic equation? Very good. The sum of roots of a quadratic equation is equal to the negative of the coefficient of the second term divided by the leading coefficient. And the product of roots of a quadratic equation is equal to the constant term or the third term divided by into the leading coefficient. And now we will check if you know how to find the sum and the product of roots of the quadratic equation. We will be providing you a multiple choice and we will give you 10 seconds to answer each question. How can you apply the sum and the product of roots in real-life situation? Thank you so much for watching this video lesson. I hope you understand the concept on how to find the sum and the product of roots of the quadratic equation. Happy learning! God bless!